Hi students. Okay. So now we have already studied what is one function, what is onto function. So from that now let us move for inverse function. Clear? So now in this particular session we shall study or we shall discuss what is inverse function. Clear? Okay. If any function has to be with inverse, that means if f is a function from a to b, if f is a function from a to b, inverse function tells that g is a function from b to a. This is very important. Clear? So if there is a function, we have one question. If the function is relation from a to b, then is there a relation in the reverse form? That means from b to a. Are you getting my point? As we move from domain to codomain with some relation, can we come from codomain to domain? That will be the question. Clear? So for that purpose we have to study inverse functions. Clear? So function tells that it is a relation from a to b where a is having unique images in codomain. A is having unique images in codomain. That means f is a function. See, f is a function from a to b. Like this. Okay. F is a function from a to b which is having unique images. Are you getting my point? Which is having unique images. That means all the terms of the domain are having unique images. That is called function. Now my question is, can I come from b to a? Are you getting my point? So that it is called as f inverse. Clear? F is in a function from a to b. So now what I am thinking is, can I come from b to a in this particular situation? Clear? So if you are coming in reverse from b to a, here this will be the domain, and this is codomain. Clear? Okay. For f, this will be the domain and this is codomain, as we all know. Clear? For f, a is domain, b is codomain. For f inverse, b will be the domain, a will be the codomain. That means you are coming in reverse path. So for that, if there is a inverse, I am telling, if there is a inverse, this particular thing will be going to be the domain and this thing is going to be codomain for the inverse function. First let us check, is it going to be inverse or not? Okay. First let us go from f, that is from a to b. See here, from a to b, every element is having unique images. Are you getting my point? Every element is having unique images from a to b. So that's why function is true. But from b to a, let us see. While coming from b to a, this particular element is not having unique image. Clear? So this particular element is not having unique images means it can't produce inverse function. Because inverse function starts with b and ends with a. Are you getting my point? So every element of b must have unique images in a. Then f inverse exists. Clear? As you all know, if the function has to be considered, it must have unique images from A to B. On the same way, if the inverse has to exist, means while coming from reverse path, here every element must have unique image. Are you getting my point? But see, in this particular situation, it will be not having unique image. So therefore, this particular thing, F inverse is not true. F inverse is not true. Have you got my point? This is function. This relation is function, but this particular relation cannot give us inverse function, because here the terms of set in B, the terms of B are not having again the unique images from B to A. That means inverse function has to exist, means again the same rule, the elements of the domain must have unique images in its codomain. As we all know, F inverse is the path from B to A. F inverse is the path from B to A. So while coming from B to A, every elements of B must have unique images. But here unique image is not present. So that's why we say that this particular relation is not true for inverse function. That means inverse function not exist. Inverse function not exist. Clear? Okay. Let us see one more mapping. See here. Let it be A and B. Let us consider F from A to B having images here. So, as you can see, from A to B, every element is having unique images. Every elements of A is having unique images in B. That means for F, A is domain. For F, A is domain, B is codomain. B is codomain. Now let us check inverse function, that is from B to A, that is called F inverse. Clear? While coming from B to A, in the reverse path, you can see that every elements are having unique images. Are you getting my point? See, every elements are having unique images. That means here this is going to be function as well as inverse function. That means this particular function exists with inverse function. Are you clear? This particular function F exists with F inverse. Are you clear? But here F will not exist. F will not exist with F inverse. Clear? In this case, F will not exist with F inverse, but in this particular case, F exists with F inverse. Clear? Because in both the paths, that is from A to B and B to A, are you getting my point? From A to B, it is function. From B to A, it is inverse function. Are you clear? That means in this case, F exists with F inverse. In this case, F will not exist with F inverse. From this, we will come to one conclusion, that there will be a condition for inverse function. Clear? So, the condition of inverse function is the particular function must be both 1, 1 and on 2. Are you clear? Once again I am telling, if inverse has to exist for any function, if inverse has to exist for any function, that function must be both 1, 1 and on 2. Clear? That function must be both 1, 1 and on 2. Here only you can see. In this example, it is not 1, 1. See, In this example, it is not 1, 1 because all elements in the domain must have distinct images for 1, 1. Are you clear? All elements of the domain must have distinct images in the codomain, then it is called 1, 1. But if you see here, this particular function is not 1, 1 because these two elements are having same image. That means it is not distinct. Clear? So for that reason, it is not going to be 1, 1. That's why it is not with inverse. That means this function will not exist if inverse. Are you clear? Now let us come to the second example. This example, see, every elements of the domain are having distinct images. Clear? Every element of the domain are having distinct images. It is 1, 1, and every element of the codomain is having pre-image. Are you getting my point? Every element of the codomain is having pre-image. Therefore, this particular function is both 1, 1 and onto. Hence, this particular function will exist with f inverse. Are you clear? So, for this particular function, what we can say, it is going to exist with f inverse. Clear? That means f is in a relation from a to b, g is in a relation from b to a. Here f is function, g is inverse function. That means this is nothing but equal to z. Clear? F inverse is nothing but equal to g. That is the relation from b to a. Inverse function is notated by f to the power of minus 1. F to the power of minus 1. See here, f is in a function, g is also function, f is function from domain to codomain, g is in a function from again b to a. That is here, for f inverse, your b will be the domain, a will be the codomain. But for the f, a will be the domain, and b will be the codomain. Are you clear? So from this we come to know that if for any function inverse has to exist, means first condition is it has to be both 1, 1 and onto. You all know that if the function is both 1, 1 and onto, we call it as bijective. Clear? The function which is both 1, 1 and onto is called as bijective function. Therefore, for any inverse, the bijective function is if and if condition. The bijective function is if and if condition. That means the inverse function will exist if and only if it is bijective. Are you clear? Inverse function will exist if and only if it is bijective. Are you clear? Okay. Next, one more thing. Please remember important point, that is f of g of x must be equal to x. Clear? This is important. Clear? F of g of x gives me the x term, means g is inverse of f. Are you clear? G is inverse of f. Are you getting my point? F of g of x equal to x means while solving the problems I am telling. While solving the problems, you understood the concept of inverse function. With that, now we are not having any problem. But while solving the problems, you have to use this condition. You have to use this condition to show that g is inverse of f. So for that reason, you must know this condition, that is f of g of x is going to be equal to x, then g is called inverse of f. Or one more thing, if g of f of x is equal to x, g of f of x is equal to x, means f is inverse of g. Here f is inverse of g. Here g is inverse of f. Are you clear? So from this we come to know that there exists an inverse function if the function is both 1, 1 and on 2, or we call it as bisective. One more thing, to show inverse function, f of g of x must be equal to x, or g of f of x must be equal to x. Clear? So from this you can understand that if f is a function from a to b, if f is a function from a to b, where a is domain and b is codomain. Again, if g is the inverse of f, if g is the inverse of f, b will be the domain, a will be the codomain. Are you getting my point? B will be the domain and a will be the codomain. That means this is f from a to b, where a is domain, b is codomain. This will be the f inverse, where we can write it as g, that means nothing but from b to a. That means here b will be the domain, a will be the codomain. Are you getting my point? So if inverse exists, domain and codomain will interchange. Clear? The domain of the f will be the codomain of the g. The codomain of the f will be the domain of g. Are you clear? So the interchange of domain and codomain will happen with f and f inverse. Clear? So from this concept, now we shall move for problems on finding the inverse image. Okay students. Now let us go for some of the problems which are already asked in your board exams and which may can ask in your board exams. Clear? So first problem is, consider f from real number set to closed interval -5 comma infinity. Clear? Given by f of x equal to 9x square plus 6x minus 5, then show that f is invertible with f inverse of root of y plus 6 minus 1 divided by 3. Okay, that means what they are asking, for this particular function, inverse function is going to exist and that inverse image must be f inverse equal to root of y plus 6 minus 1 divided by 3. Are you getting my point? So we have to show that this is the inverse function. Clear? Okay. So for that reason, first let us write f is a function from R to minus 5 comma infinity, defined by f of x equal to 9x square plus 6x minus 5. Clear? They are asking show that inverse image is that. Okay. So for that reason, first let us go for 1, 1 function. Clear? So first let us show it is 1, 1 function, then let us show it is onto function. So if it is both 1, 1 and onto, inverse must exist. Clear? Okay. For 1, 1 function, that is f of x equal to, for that I will write it as f of x1, that is equal to 9x1 square plus 6x1 minus 5. Clear? I will also write f of x2, that is equal to 9x2 square plus 6x2 minus 5. You can see my link of the video where I have explained 1, 1 function and how to show 1, 1 function in the corner. Clear? Okay. Here these two conditions we are taking. Let us choose if f of x1 equal to f of x2. If we consider f of x1 is equal to f of x2, I have already explained in the previous video that you can see in the corner where we have to prove it as x1 equal to x2. Okay, so f of x1 equal to 9x1 square plus 6x1 minus 5, that is equal to 9x2 square plus 6x2 minus 5. So now cancel minus 5 and minus 5. Both are same terms, no problem. Now further simplifications, clear? So further you can solve it as, see, you take all the terms on LHS, what you are going to have? 9x1 square. If I take all these terms on this side, so you can write it as 9x1 square minus 9x2 square plus 6x1 minus 6x2 equal to 0. These terms you can write. Okay. See, from this 9 is common, so that's why 9x1 square minus x2 square plus 6x1 minus x2 equal to 0. Clear? Okay. So now let us calculate. x1 square minus x2 square, x1 minus x2. So from these two, I can take common x1 minus x2. I can take common x1 minus x2. So remaining terms are, here 9 is remaining, 9 into x1 plus 9 into x2. Here 6 is remaining. So that is equal to 0. Clear? You have two choice. Either this must be 0 or this must be 0. But here 9x1 plus 9x2 plus 6 cannot be equal to 0. From these two, this term cannot be equal to 0. You can see directly. So from this it implies x1 minus x2 equal to 0. Therefore x1 equal to x2. Hence it is 1 1. Hence it is 1 1. See very carefully, because I am going to rub the things and I am going to write onto function, because there is no space to write for the onto function. So for that reason, see again very carefully. First the function will be given. So for that you have to prove both 1 1 and onto. You have to prove both 1 1 and onto. So for that reason you must be perfect while solving. Okay, so you have to be perfect while solving. From this we can see that to show 1 1, f of x1 you have to write, f of x2 you have to write. You have to consider this. For the example, if for in the place of f you can write also consider, you can write like this: consider f of x1 equal to f of x2. These two terms are going to be equal, cancel. See the simplifications, you must be perfect with the simplifications. You feel that it is easy, but in exam it will leave your hand. Clear? So for that reason, be perfect for solving these 2-3 steps. Clear? Here take all the terms on LHS, take the common terms outside. x1 minus x2 is common, write the remaining thing, it is not equal to 0, therefore x1 is equal to x2, hence it is 1 1. Hence it is 1 1. Okay. So now let us go for onto function. Let us go for onto function. Clear? Now 1 1 function is over, and now let us go for onto function. For onto function, you have to write f of x equal to y, where it is notation. Again, I have explained the onto function in the previous video. You can see in my link. Clear? So, f of x equal to y, that is notation. F of x equal to y, that is notation. Again, I am telling, I have already explained how to show onto function. If you have doubts, go through my previous videos which are in the corner link. Clear? So first you take this notation and you write y equal to, that is 9x square plus 6x minus 5. You write this term 9x square plus 6x minus 5. Okay. So after writing this you have to simplify. That is y equal to, this has to be simplified. See, I will write it as 3x plus 1 whole square. I will write this as 3x plus 1 whole square. If you have doubts, what you have to do, you have to divide this 9 by 3. You have to divide this 9 by 3. Clear? That means 3x plus 1. Clear? So for that reason, you can write it as 3x plus 1 whole square. If you simplify this, what you are going to have? 9x square. If you simplify this, you are going to have 9x square plus 1 plus 6x. Clear? See, 9x square is already present, 6x is already present, but 1 is not present. So for that reason, I will write it as minus 1. For that reason, I will write it as minus 1, and here I will write minus 5 as it is. Clear? The simplification of this I will explain in regular classes, in your regular classes, no problem. There is a method of writing this form, so that particular form I will explain in your class time. But here just you take on that 3x plus 1 whole square. Clear? If you have doubts, see, if you divide 6 by 2, you will get 3. That much you remember. If you divide 6 by 2, you will get 3. That is what the hint of this particular element. This type of problems will come in integration also. So there we shall discuss for more. Clear? But now here let us don't go in details. I will just explain 3x plus 1 whole square minus 1 minus 5. This 9x square plus 6x minus 5 will be written as 3x plus 1 whole square minus 1 minus 5. This you have to practice. Clear? Otherwise you remember, divide 6 by 2, you will get 3. So that 3x here you have to write. Clear? Okay, so 3x plus 1 whole square minus 1 minus 5. If you simplify this, you will get 9x square plus 6x minus 5. Keep it in mind. If you simplify this complete term, you will get 9x square plus 6x minus 5. Okay, so minus 1 minus 5 will be minus 6. If I take that minus 6 on LHS, it will be plus 6. It is going to be equal to 3x plus 1 whole square. 3x plus 1 whole square. You apply square root on both sides, so it will be square root of y plus 6 equal to 3x plus 1. Clear? So now if you simplify this, you are going to have x equal to root of y plus 6 minus 1 divided by 3. Divided by 3. Clear? So this is how you have to prove onto function. This is how you have to prove onto function. After writing this, you have to write the definition of onto. What is the definition of onto? See here, I will write it. Now I will remove all these terms because there is no space. Clear? What you have to write for onto? That is, the continuation of, see, the continuation of this I will write here. Clear? For every y belongs to closed interval minus 5 comma infinity, for every y belongs to closed interval minus 5 comma infinity, there exist x belongs to R. There exist x belongs to R, hence it is onto. hence it is onto. Clear? Okay. Hence it is onto. Okay. So now after getting onto function, you have to write inverse function. If you get any doubts here, you can clarify. 9x square plus 6x minus 5 has to be written as 3x plus 1 whole square. I think you are understanding this term because 9x square has to be written in the form of square. Clear? 9, that means 3 square is 9. Are you getting my point? That means 9 equal to which terms square? That is important. 9 equal to which terms square? That is important. So here you are going to have 3x. Y plus 1, here you have 6x. 2 into 3x will be 6x. Into 1 must be again 6x. That's why it will be plus 1. For that there is one shortcut. I will tell you later. But now let us go forward. Clear? Okay. Here minus 5 comma infinity, there exists x belongs to R, hence it is onto. So for inverse image, see here, f of x equal to y. This is your function. F of x equal to y. This is your function. Now, this implies f inverse of y equal to x. This implies f inverse of y equal to x from onto, see there, x equal to what? From onto, we can write f inverse of y equal to x is what? See here, x is root of y plus 6 minus 1 divided by 3. From onto we know what is x. From onto what is x we already know. So f of x equal to y. If I take f on the other side, or if I take the inverse of f, it will be f inverse of y equal to x. Hence, f inverse of y equal to root of y plus 6 minus 1 divided by 3. This much you have to write in your exam so that you can get the details of that problem and the complete marks that is distributed for that particular problem. Clear, students? So here you will be having the doubts with how to write this and particularly these things. How this is going to be f of x equal to y implies this term. So here and here definitely you are going to have a doubt. Clear? So for that doubts I am going to clear here only after removing all these terms. Clear? First you see how you are going to write this step. In that particular step you are going to have a doubt. So that doubt let us clarify. Clear? So let us clarify this particular doubt, how to write this step. Clear? Again, let us take one example, that is 9x square plus 6x minus 5. How this term is going to be written? Like this. Clear? So for that, what I will do, I will write a bracket, I will write square. Clear? These all terms are in the form of shortcuts that you have to remember. Write a bracket and square. Now, what is your first term? 9x square. What is your first term? 9x square. Clear? So, you have to think, if I square which term, you are going to get 9x square. Are you getting my point? If I square which term, you are going to get 9x square. That means you all know 3 square is 9. So for that y 3x. Are you going to get 3x? Clear? So you will get 3x. So here you have plus, write plus as it is. Now, what you have here? 6x. So that's why 2 into 3x. 2 multiplied with 3x is how much? 6x. This term multiplied with the term here must be again 6x. Are you getting my point? 2 into 3x is 6x. This term multiplied with again the term you are going to write here, that also must give you 6x. That means 2 into 3x is 6x. 6x into 1 is again 6x. So for that reason 3x plus 1. Clear? Here what is 1 square? 1 square is 1. Clear? So for that reason here you have plus, here you must write minus. Again I am telling, don't worry about this sign. It can be plus, it can be minus. Don't worry about that. The term what you are going to have here, the square of that and minus. Are you getting my point? Don't worry about this term. Clear? Here you have 1. 1 square is again 1. Write it with minus sign and minus 5 as it is. This is what written here. Clear, students? This thing I can't explain there because we are solving the problem. In particularly I am explaining how to write this as 3x plus 1 whole square minus 1 minus 5. Clear, students? Okay, this is one thing. Let us take one more example. That is 4x square plus 12x plus 15. I have to write it in this form. Clear? What you are doing? Take a bracket, put square. What is first term? 4x square. If I square which term, you are going to have 4x square. Are you getting my point? If I square which term, you will get 4x square. That is nothing but 2x. Because if I square 2x, it will be 4x square. This is over. Now let us go for 12x. 2 into 2x is how much? 4x. 2 into 2x is how much? 4x. Here you have plus, write as it is. 2 into 2x is 4x. If I multiply with which term, you are going to have 12x. See, 2 into 2x is 4x. If I multiply that 4x with which term, you are going to have 12x. That is 3. Clear? So now it will be 2x plus 3 whole square. Now what you have to write here? Pause the video and think. What you have to write here? You have 3 here. Clear? You have 1. Here you have 3. Now think what you have to write here. Pause the video and think. Clear? Here if there is a 3, here I must write minus 9. Because 3 square. 3 square is 9. I should write it with minus sign plus 15 as it is. Plus 15 as it is. Clear, students? So this is how we are solving this particular step. Okay. I think your doubt is cleared. Again, now let us go for your last step. In the last step, we have written inverse image as f of x equal to y implies f inverse of y equal to x. This we have written. Some of the students again get confusion here while writing the inverse image. How f is going to be f inverse of y? Clear? So for that I am writing in the problems directly. This thing is written directly in the problem. But now let us see how this is possible. Take this given term f of x equal to y. Apply f inverse on both sides. Apply f inverse on both sides. F inverse of f of x equal to what? F inverse of y. So now we know that the function is both 1, 1 and on 2. Then the inverse image must exist. Are you getting my point? We know that it is both 1, 1 and on 2. Inverse image must exist because it is both 1, 1 and on 2. You go previous. In this video you see from starting I have explained what is inverse image and how to show inverse image in the problem. F of g of x. You remember? F of g of x is equal to x. This thing I have already explained where g is inverse of f. G is inverse of f. See here. F inverse of this f. Clear? F inverse of this f. will give you what? According to that, it will be x equal to f inverse of y. I think this doubt is also cleared. You know x is equal to this term, that term has to be written here, then your problem is over. I think all the doubts are also cleared in that particular problem, because it is a very important kind of problem where it is asked in so many exams of your board. Clear? So that's why I am explaining all the terms in detail so that you must not have any confusions. I think now this step is cleared in the writing of inverse image, how this thing is going to be. That is also cleared. From that you come to know that there exists an inverse image where f inverse of y equal to square root of y plus 6 minus 1 divided by 3. Clear? Root of y plus 6 minus 1 divided by 3. Okay students, so this was your one of the problem. So in the next session I will continue with the next examples.